Hello, my friends. This puzzle is called Mostly Clover, and that's me. I'm entirely Clover, but this puzzle was not posted by me. This is the gas posted by Philip Newman on June 29th, 2024. And it's called Mostly Clover because lately Philip and I, and admittedly mostly me, have really been riffing on this particular XV pairs constraint that you can see in this grid. And in this constraint, you have some x's and some v's in the grid, and digits that are separated by an x have to sum to 10, and digits that are separated by a v have to sum to 5, and that it's not necessarily the case that all possible x's and v's have been given in the grid. It's also possible that there are other pairs of digits that have those sums that haven't been marked in the grid. So you'll see a lot of that constraint in coming days. I have set a whole bunch of puzzles that have a combination of the XV pairs constraint and also something else in them. And so there will be a lot of that over the next weeks, but this is Philip kind of kicking off the little constraint event by sharing an XV pairs region sum line Sudoku. So I already explained XV pairs. Um, on top of that, we have normal Sudoku rules, so we're placing the digits 1 through 9, once each in each row, each column, and each outlined 3x3 region. And then these blue lines are region sum lines, so when you see a blue line, it goes through multiple regions, and in each of those regions, the sum of all of the digits along that line has to be equal. So for instance, the sum of these three digits is going to be equal to the sum of these three digits. The sum of these two digits will be equal to whatever this digit is, and that will also be equal to whatever the sum of these two digits is, and so on. So the first thing I notice is these long lines in kind of this square formation around the outside edge of the grid. I don't know exactly what these two digits are, although I know they can't be higher than 4. I do know, however, that they have to sum to 5. Because they sum to 5, I know that the sum of these three digits is 9 plus 5, which is 14. And because of the region sum lines, and this is like a very elegant little piece of setting, the sum of these three digits is also 14. However, I know that these two sum to 10. So if these two sum to 10, and then all three sum to 14, this must be a 4, which makes that a 1. Now I can fill out this V clue because it can't be 1 and 4 because this cell can't be either 1 or 4. So this has to be a 2-3 pair, making that a 1-4 pair. This could still either be 1, 2, 3, 4, but what's important here is that we know that its sum is 5. 5 plus 8 is 13, so the sum of all of these digits is also 13. Because this is 10, the remaining digit has to be a 3, which makes that a 3 and a 7. These are also going to be 1, 2, 3, 4. I'll just pencil mark those because we know they have to sum to 5, so they can't be any bigger than 4 individually. Same idea, 6 plus 5 is 11. These sum to 11, therefore that is a 1. 7 plus 5 is 12. These three therefore sum to 12, so that is a 2. So we're going to place a 2 and an 8 there. And I'll mark in a few more pencil marked options and a few more kind of definitive known results on some of these X's and V's clues. So this can't be a 2-3 pair, because if it was, then we would have 3 cells that could only contain 2 and 3. So that must be a 1-4 pair, which makes that a 2 and a 3. And now because there's a 3 in this region, this has to be a 1-4. It can't be a 2-3. This is a 2-3. This is now a 1-4 because it can't be 2-3 without having the same problem we had up here in the top corner. So that's a 1 and a 4. Oh, and we can also resolve this real quick. And this is now a 2-3 pair, and I think that gives us all of our V clues. So let's start working on some of the X clues. So we can't use a 2 or a 3 here, so this is either 1 and 9 or 4 and 6. We don't know which it is yet. We can't use a 1 or a 4 here, so this is 2 and 8 or 3 and 7. We can't use a 2 or a 3 here. So again, this is 1, 9, 4, 6, and we can't use a 1 or a 4 here because those are in the region already, so this is either 2 and 8 or 3 and 7. Now, how about this X clue? So we can't go 1 plus 9, because 9 is taken. We can't go 2 plus 8, and we also can't go 4 plus 6, because we know there's a 4 in that region. So this has to be a 3 and a 7. And then by the same reasoning, this has to be a 2 and an 8. Okay, so now we know what these three digits are, and we know what these three digits are. So these three digits are going to be 5, 6, and 8, and the critical thing to note there is that that includes an 8, which means this can't be a 2-8 pair. So that's a 3-7 pair, which makes that a 2 and a 3 in that order. And we now know that these are going to be a 2 and a 9. Same thing going on here, except with different digits. These have to be 5, 7, and 9 to finish the region, so that can't be a 3-7 pair. That must be 2 and 8, so that's going to be a 3 and a 2. And by the way, the 2 and 3 I just placed here will resolve these unknown pairs. Okay. These cells are now going to be in the row 3 and 6. Okay. Vertically here, I need 5, 6, and 8, but because there's an 8 in the region already, 8 can't go in those cells, so that's going to be my 8. And now because there's a 6 represented in this pair, this is definitely not 4, 6, that must be 1 and 9, which resolves this 4 and this 1. My last two digits here are 4 and 7, which makes that a 3 and a 7, which makes this a 6 and a 3, and actually we're really just resolving everything here. And these cells contain 5 and 8. There's a 2-8 pair there, which makes this a 5 and makes this an 8. And these are going to be 5 and 9, and these are going to be 7 and 6. Finishing off this region, we still need a 5, 6, and 7. 7 can't be in those cells, so it goes up here. That's not a 7, okay. That's also not a 7 because there's 7s here and here, so my 7 goes right there. So now these cells are going to contain a 5 and a 9 to finish the column. Therefore, this can't be a 1-9 pair, so it's a 4-6 pair. And we can resolve a few things via Sudoku from there. The 9 in the column gives us a 2, we have an 8 there and a 2 there. And let's pencil in what else we have going on here. So that's 5 and 6, and this is going to be 8 and 9. Awesome. Let's use some of our lines now. So we have a 5 plus 3, which is in fact equal to 8. So these two digits also have to equal 8. Now they can't include 3 at all because there's already a 3 in both of those columns. In fact, let's just go ahead and place a 3 in the central region. I just noticed that I can do that because I have 3's here, 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 and here. Whenever you have 4 of any given digit in all 4 of the regions immediately surrounding the center, you know that you have a hidden instance of that digit in the center region. That makes this a 3, and via similar logic, this cell must be a 2. And because we have these x's, that will be a 7, that will be an 8. So now we know the sum here is 8 because of this region sum line, so that must be a 6. And the sum here is 7 because of this region sum line, so that must be a 4. That should give us enough to resolve the rest of the puzzle via Sudoku. Let's have a look. So that's got an 8 in the column, so that'll be a 9, and that must be a 5 and a 6 and a 5. That will now be a 1, and our last digit in this region is a 9. Okay. And 6 and 4, 9 and 5, and 1 and 8. And that is how you solve Philip Newman's Mostly Clover. Hope you guys enjoyed that one. If you want to solve it yourself, the link to solve it is in the description of this video down below. And I hope you enjoyed the puzzle, and I'll catch you next time.